Dear children, in the previous video we have studied about what are the rational numbers, natural number, whole number, integers. Okay, today we'll study the classification of rational numbers. So rational number, so there are two integers, that is integers and non-integers. So in non-integers, fractions and decimals are there. Then in integers, negative integers, whole numbers. Then in non-integers, there are two parts again, terminating and non-terminating. So for non-terminating, you can call it as a recurring also. So the whole number is nothing but a 0 and the combination of 0 and natural numbers. Okay, so rational number, it has two parts, integers and non-integers. In non-integers, fractions and decimals. So in integers, negative integers and whole number. Because why I have taken only negative integers here? Whole number starts from 0, 1, 2, 3 and 4 and so on. And negative integer starts from -1, -2, -3 and so on. So that's why. So integers, it is a combination of negative integers and whole integer. So what about whole number then? Whole number is a combination of 0 and natural numbers. That is 0. Natural numbers is 1, 2, 3 and so on. So this is combination of 0 and natural numbers. So yesterday we studied all these things, including non-integers also. So today we'll see terminating and non-terminating, or you can call it as a recurring. Okay, so let us understand terminating decimal numbers by some examples. Okay, we can understand all these terms through examples. So I'll take, this is 5 by 10 is a rational number. 5 by 10 is a rational number. So I can write it as a 0.5 in the decimal form. Then if I take 5 by 2 as a rational number, then I'll write this one in a decimal as 2.5. Then 7 by 4, this is a rational number. If I write this one in a decimal number, then I'll get this one as a 1.75 and so on. You can write any rational number in a decimal form. So these are called terminating decimal numbers. So what about non-terminating or recurring decimal numbers? Non-terminating means, recurring means what? It's repeated. Okay, so suppose this is 2 by 3 is a rational number. If I divide 2 by 3, then what we get? I will get the result as 0.6666 and so on. Or you can write it as 0.6. So this is a repeated term. Suppose if I take 1 by 7 as a rational number, then after dividing 1 by 7, then I'll get 7 ones are 7, 4s are 28, 2s are 14, 8, 5, then 7. Again, if you go on multiplying, then again we get 1, 4, 2, 8, 5, 7. So 1, 4, 2, 8, 5, 7, 1, 4, 8, 2, 8, 7. So this is, and so on. So, or you can write it as 0.142857. So this bar indicates what? Repeated terms, repeated. So this 1 by 6, next example 1 by 6. So if you divide 1 by 6, so what you get? 0.6, 1 is 6, 4, then 6, 6, 6, 6 and so on. Or you can write it as 0.16, but I'll write this bar only on the 6th position, because here 1 is only one times it is occurring, but 6 term is occurring many times. So on the head of this 6, I'll write, I'm drawing this one. This bar indicates what? Repeated terms only for 6, not for 1. So these all are called non-terminating or recurring decimal numbers. Let's see some examples. I'll take example. Find the rational number. Find 3 rational number equivalent to find 3 rational numbers equivalent to, I'll write 3 by 5. So 3 by 5 is a question. You have to write 3 equivalent rational numbers for 3 by 5. So first one is, this is 3 by 5. I'll write 2 by 2. And second one, again 3 by 5. I'm multiplying both numerator and denominator by 3 by 3. Then third, 3 by 3 into 4 by 4. Okay, now see here. 3 2s are 6 by 10. This is 3 3s are 9 by 5 3s are 15. This is 3 4s are 12 and 5 4s are 20. So therefore 6 by 10, 9 by 15 and 12 by 20 are equivalent to the given rational number. 3 equivalent terms given to the rational number, that is 3 by 5. Okay. Then example 2. Express 5, the integer 5, as a rational number. As a rational number with denominator 7. So solution. So 5 is a given integer, so we have to write 5 as a rational number with the denominator as a 7. So 5. So 5 I can write it as 5 by 1 in the form of p by q, which is a rational number. So with 7 as a denominator means 7, then multiply again numerator also by 7. What we get? 5 7s are 35 by 7. 35 by 7. So what about 0 then? If I take 0 as an integer, second example, if 0 is an integer, so we have to write this one in the form of rational number with the denominator 7. So 0 by 1 I can write into 7 by 7. So this is 0 by 7 is a rational number. Okay, this is a rational number. Then example 3. So express 3 by 5 as a rational number with denominator 20. So this is a given rational number 3 by 5. So you have to write a rational number with denominator 20. So to get denominator as a 20, so what we should multiply this 5 so that we can get 20. So here, so 5 4s are 20, alright. So this 4 we have to multiply on the numerator also, so that if you multiply 5 into 4, then you get denominator as a 20, then 3 4s are 12. So 12 by 20 as a answer. Then I'll take example 4. Example 4. Find Find x such that minus 2 by 3 is equal to 6 by x. So we need to find out the value of x here. Okay, value of x. So after cross multiplication, so minus, we'll write this one as minus 2 into x is a minus 2x is equal to 6 into 3. 6 into 3. So we are finding the value of x here. So I'll write therefore x is equal to 6 3 is a 18 by minus 2. So 2 ones are 9 are, so minus 9 is the answer. So x is equal to minus 9 is the answer. So I'll take one more example in this. 7 by minus 4 is equal to x by 8. X by 8. So after cross multiplication, so we have to write 7 into 8 is equal to x into minus 4. So 7 8s are 56. So x into 4 is a minus 4x. But we are finding the value of x here. So write x is equal to 56 by minus 4. So what we get? Minus 14. Minus 14 is the answer. Minus 14 is the answer. So I'll give homework. Solve exercise 2A. Thank you, students.